All right,
Good
fishbowl
now?
can
Okay.
start.
So I think first we should go over vocab.
Okay.
What did you guys get? You have.
I said like independent and dependent variable.
I said.
yeah.
Oh, go ahead.
How about just going to circle right there?
Okay. I said x-axis and y-axis.
Oh.
I said equations.
You just skipped me. I said unit rate.
That works.
I said dependent and independent variables, linear relationships, and changes.
I said like graphs, equations, and tables.
Okay, so for number 1, it says describe how the dependent variable changes as the independent variable changes in a linear relationship. And first you have to restate the question. So how did
we
anyone
do that? I said the dependent variable changes as the independent variable changes in a linear relationship by, and then I continued.
I did the same thing.
Yeah.
Does anyone else have a different answer?
I have the same thing, but because at the end.
Oh.
Nice.
Okay, and then like, what did you guys answer with?
When it is linear, you have to change your y-axis with the x-axis so it can stay linear.
Yeah. I said the dependent variable depends on the independent variable, and then think of it like a table. If the independent variable changes, so does the dependent, and that's what I did for my example or table.
I said the same thing as Presley, but I also said that it will either be a positive rate or a negative rate depending on what the rate of change is.
That works.
I basically said what you guys said, and I said it'll change at whatever rate, whatever what the rate is, depending on the independent variable.
I said that if it's linear, both of the oh wow, I can't think of the word now. But they have to change it. They both have to have a constant rate so that it goes up in a straight diagonal line. Yeah. Or
I said if you change the independent variable, the dependent variable will change.
What did you do for an example?
Are you getting it, Jim?
Oh.
I forgot to do an
Okay, pause there. So, remember, the sharing is great, but listen to what they say, especially on the outside, so that if there's something that you can add to maybe help one of their responses, do that. And something I would add to Jay's would be, it changes by the rate.
Okay.
Okay, back to you guys.
All right. And my example is just really short because I shortened it, and it looks like that. You guys can see. Yeah, graph is easy.
Yeah.
And equation.
What I did is I did an equation and a table because I wanted to show that like this would be your rate of change, and since mine is positive on the table, it's going up instead of going down. Yeah.
Nice.
I just did like miles and
Yeah, that works.
like how much you get.
I just did a table and then made a graph that kind of goes with it. It's very bad. Yeah, to show the constant rate for both.
I started the table on miles and hours, but I didn't finish the table.
Okay.
What does the rubric say about your examples? To be explained.
Oh gosh.
Doesn't have to be a lot, but now you can do explaining with some labeling, telling him what those units are, stuff like that. But usually you need a sentence or two that kind of connects what you drew. So when it says, for example, you've got for example.
And I explained my table by saying, like, as you can see, when the number of people changes, so does the amount of money, because in this case it's a charity.
Okay. For my example, I did a table of 20, 10, 30, 16, like going on and so forth, and like it's all like it's mixed up, but it's still linear. And then showed it on a graph of it said like that.
That works. Did anyone?
What for explaining or for describing my example, I wrote if the independent variable is x and the dependent variable is y, and then I showed my equation, and then to go with that equation, I made a table.
That worked. Did you get your example?
No, not yet.
I said, well, I just like added to it, but I said in the table both the y and x axes, so like the size in the table, go up with the constant rate. So yeah, the line would be.
Okay, we are out of time. All right, guys. Thank you for those bits. Good job. Okay, we're gonna go with
We're fish.
Anthony and who's the other person at your table?
Chloe.
Oh, and Jaden's not here. So Anthony's in, and then we're gonna go the middle group. So Anthony in the middle group, and then we'll take Allie B out of the back. Allie B join them.
Only because I don't have
Never. I would never do that.
Yeah, you would. That's what
Allie,
you just
Allie.
did.
I would never do that.
Never.
Right? Yeah, just problem 2.
I lost mine, so
Who
I had
else is in the middle?
Guys, I lost
Carl.
mine.
Carl.
Carl.
Antoine.
You
I
were
lost
in
mine,
the
so I had to
And who's
redo
the
it,
other
so I
middle
don't have it
person?
written down.
Oh, so it was me, Carl, Scarlett.
Oh, Scarlett's not here. Scarlett? Wow.
Scarlett's not
Okay.
here.
Out of nowhere.
All right. And yeah, let's get going. Okay, you guys go.
Okay, so how does you restate the question? Read the question.
Okay.
It says, how does the pattern of change between two variables in a linear relationship show up on the table and equation? And I haven't wrote anything yet, but I thought about it. And it'll change because, or it shows up in the table, because in a table when one side changes, the other side changes. And it shows up in a graph because, say it's
Equation.
Oh. It shows up in an equation by, it would be something like, haven't gotten this far yet, but so if it's D equals 1 times the, say it's weeks, D times 1 time, D equals 1 times weeks.
I restated it by saying the pattern of changes between two variables in a linear relationship shows up on an equation and a table by, and then
I said the pattern changes between two variables in a linear relationship show up in a table, and then I answered that, and then I did, and it shows up, and then after that it shows up in an equation because
I just said a pattern of changes between the two variables in a linear relationship shows up in a table/equation by,
I said the pattern of changes between two variables shows up in a table and equation because.
Yes.
Alright,
So we all have
what'd
to
you
do
get?
the same thing. Well, I did graph instead of equations, so that's not there. And for the table, I said you could see a constant of proportionality or a unit rate between both the independent and dependent variable. And I showed that as an example by drawing a table, and then I haven't finished it, but the independent side is going up by 2, so that's the rate for that side, and then on the dependent side, the rate is up by 1.
I said in a table, when the independent variable changes, the dependent variable changes with it, because the independent variable is on the left side, and when the left side numbers go up or down, the right side numbers follow it by a constant rate.
Okay, so a pattern of change. Okay, never mind. Just it shows up in a table because the table, like, you can see a constant rate, and the independent variable depends on the dependent variable. So whatever happens to that, it goes up by a constant rate with the variable. Yes.
All right, what'd you get for your?
Is that your? That's the example I already said.
Oh, it's my turn. Okay. What am I supposed to say again?
Whatever you want. That's part of the fishbowl. Like, you can talk about the problem however you want.
Okay.
This is your opportunity to get to either ask questions, get help, share. Look at the rubric. What's something that we could else talk about? Look at the rubric.
What did you guys get for the equation?
I didn't get the equation. I didn't explain it very well.
But like,
Oh, for
did
my.
you explain it?
Oh, so no. So I just I just did a table and then I wrote up an equation for the table.
So how would you explain it? Like in the, for example, line box? No.
So I drew something like.
Yeah.
Like that, and I said, for example, if this side changes, over here, if this side changes, that means that this side will also change. So if this side is 1, 2, 3, 4, you could tell that it goes up by 5 on this side.
So then the equation going with
That's
it
it.
will be
Rate.
yes.
I did the same thing, except different numbers.
Ben.
Okay. So how?
Let's go to the outside. Things that you thought they did well. Yeah, Anderson.
I thought they did well on explaining and their examples.
Yep. It seems like they have good illustrations or good examples that go with it, as well as an explanation. What else did they do well? Sylvie?
All of them talked like an even amount. It wasn't like one person.
Yeah, I thought that they did a really good job. They kind of did go in a circle. Don't need to do that, but that's okay. What else? I thought they did a good job in making sure they answered both pieces. Because there's 2 pieces there. It says table and equation. So you have to answer both. All right. Thank you, guys. Last group, come on up. Yeah.
Ready for this.
Here you go.
Who's the best surrender?
All right, guys. We got about 4 minutes. Here we go. 3 minutes. It's gonna be a shorter one.
How does the pattern
Yeah, I know. I fixed that typo.
There's also one on the other.
I know. I fixed that one too.
the 2 variables in a linear relationship show up in a contextual situation? How do you guys restate your?
So similar to question 2, I restated it by saying the pattern of changes between 2 variables in a linear relationship show up in a contextual situation such as or by.
Yeah, I'd agree with that.
Okay, sounds good.
Well, like contextual means like a real life scenario, right?
Mm-hmm.
Yeah. So, but like, did anybody like finish it? I finished it. Go ahead, you can go.
I didn't finish it, but I'm thinking about how to explain it.
Did you finish it? Okay, then you go.
Okay. I said a pattern or changes of two variables in a linear relationship show up in real life when you're at the store. When you walk into the store, you have an even amount of money, which is $20, and you spend money at a constant rate, and they'll end up in the negative. The two variables are the $20 and the $2.
Okay.
And again, we just.
Do you finish yours?
Almost. I'm drawing something like that.
So should I go?
Sure.
I said the pattern of changes between the two variables in a linear relationship shows up in contextual situation because you can see the unit rate between the changing of two variables. For example, if you wanted to buy 2 markers that are $1 each, including tax, you would pay $2. And I also did a drawing, I guess? Graph? I don't know.
A graph or a table showing.
What I did was, like, if there was like a dog walking business, you could have like one dog for $5, how long the walk is or anything, and then like if you walked 5 dogs, you would get $25.
Okay. I was just thinking about it, and I was like, well, so like if you go to an amusement park, you know, and you have like $60 to spend, so like 30 of that gets you in, and then you have 30 left. So you just keep buying snacks, but everything costs the same amount. So, and then like you buy, say, 10 snacks, and you spend all your money. Like say every snack costs $3, and then you buy 10 snacks, and then you lose all your money. And so both, it's like
Another
so.
situation.
Yeah.
Okay, good. Great job. That was really good. I love how you guys talked about restating. Very good job. Okay, we need to put the chairs back where they belong. Clipboards go back. We're going to leave the whiteboards right here. Okay? And calculators need to go back in there. Remember